Brought to you by Penguin.
The Mathematics of the Gods and the Algorithms of Men by Paolo Zellini. Read by Mark Elstob. Introduction. About which reality does mathematics speak to us? It is widely supposed that mathematicians preoccupy themselves with abstract formulas, and that it is only for inexplicable reasons that these formulas have applications in every area of science. We conceive of immaterial entities that seem subsequently to be destined to define models of phenomena that actually occur in the world. On the one hand, there are real, present things. On the other, mathematical concepts, creations of our mind, which simulate their behavior in a more or less effective way. Ignorance of the true reason behind the descriptive power of formulas and equations certainly doesn't help to clarify the underlying motivation behind mathematical thinking. It gives currency, instead, to the idea that mathematicians are not inclined to engage with the world. Mathematics continues to present itself as a science that elaborates ingenious operations with rules and concepts that seem to have been conjured up with the sole aim of their being executed correctly. It matters little that some of these ideas have been suggested by the observation of natural phenomena. The operations rapidly produce advanced and complex concepts that distance themselves from observable reality, and ultimately confirm the distorted image of mathematics as a merely linguistic game, or a series of empty formulas. If we turn to its remote history and to its deepest purpose, however, mathematics appears to be orientated very differently than is commonly supposed. Its origins allow us to understand that ancient arithmetic and geometry were beginning to assume the role not so much of describing or simulating real things, as offering a foundation for the very reality of which they were a part. It was concrete things themselves, those that were directly and immediately perceivable, that were shifting and mutable, and therefore prone to appear unreal. To find precisely what removed them from such instability and evanescence, one had to look instead to numbers, to their relations, and to the figures of geometry. If we think about Zeno's famous paradoxes, the number points of the Pythagoreans and the atomists of antiquity, about Plato's mathematical philosophy, the discovery of incommensurability and the significance of the concept of relationality, logos, about Babylonian calculus and Vedic mathematics, we are faced with a great mass of knowledge designed to capture the most internal and invisible, as well as the most real, aspect of the things that exist in nature. The theory of numbers and of continuous mathematics, elaborated in the 19th century, presented itself as the ideal continuation of ancient Pythagoreanism, and of a vision of the world inspired by an intuition of the atomistic nature of reality. Mathematicians of the period, then, continued to contend that their symbolic constructions corresponded to very real entities, and the widespread impression was that on the success of their theories depended the foundation of knowledge that was necessary for understanding the world. When, in the early 20th century, the principles of these theories became uncertain and began to undergo a critical revision, mathematics was obliged to search for the reasons that make a system of calculation genuinely concrete and reliable. At this time, a key term began to circulate persistently among mathematicians: algorithm, a word which denoted not so much an abstract formula as an actual process. This process needed to unfold in a finite number of steps, from an initial set of data to a final outcome in space and time, according to the modalities predicted by a machine. The formal definition of algorithm, based on recursion, on Turing's machine, or on other formulations, dates back to the 4th decade of the last century. But the first indications that it would be this concept of algorithm that would inherit the sense of mathematical reality, that is to say, all that mathematicians consider to be real and actual, were already being witnessed in the first decade of the 20th century, in the early signs of mathematical
Sample complete. Ready to continue?